Okay, welcome to this tutorial over exponent properties. In this tutorial, we will solve all the problems from this homework assignment, and hopefully this will be a lucid and relatively painless exploration of the exponent properties that we encounter in Algebra 1. So let's begin with number 1, and we're going to start by rewriting this thing. We have u v to the negative fourth power, and then we have a times symbol here, and a 4, then a u to the 0th power, followed by a v raised to the power of negative 2. All right, so there's a number of rules that we're going to encounter here in this problem, which is good. We get a chance to kind of look at everything. Now, the very first thing that I recommend doing when working with exponent property problems is to put a 1 with any variable, and quite frankly, any number that doesn't already have an exponent, because you might need it. It will help you later, okay? All right, so the first thing we do is identify any common variables, all right, common terms. And I see that I have 2 u's and I also have 2 v's. All right, so we're going to be applying a property here called the product property of exponents. Okay, so what that means is if I have x raised to the power of m times x raised to the power of n, that is equal to x raised to the power of m plus n. So in other words, when you multiply and the bases are the same, these are called bases, you add their exponents. All right, so keep that rule in mind now, because we're going to combine these together. Okay, this is multiplication, but we're going to add the exponents. So this is going to be u raised to the power of 1 plus 0. That seems like a superfluous thing to write, but it's important that we understand what's going on in terms of the properties. And then let's do the v's. Okay. Now I've got v, so there's a multiplication symbol that's understood here. V raised to the power of negative 4 plus negative 2, right? So negative 4 plus negative 2. And then don't forget about the constant term 4, so we just multiply that there at the end. All right, so now we're going to work with this. So we see we have u. Now, when we do 1 plus 0, that's 1, but we don't write the 1. Like, you could write the 1, and that's not mathematically incorrect, but it's just not done. It's understood that there's an exponent of 1 when there is no exponent written. So we'll go ahead and just write u, and then we'll write v. Now, it's understood that there's multiplication occurring between these two. It's often not written. And now negative 4 plus negative 2 is actually negative 6. And then we multiply the 4 in at the end. Okay? But we're not done yet. You see, we have here, a little sidebar here, we have v to the negative 6th. Now, negative exponents are frowned upon. And so there's something called the negative exponent rule, which means if you have v to the negative 6th, you're going to fix that by putting 1 over v to the 6th. So these two things are equivalent to one another. So let's look back here at our problem. Instead of writing u v to the negative 6 times 4, we're going to write 4u. Again, it's just good form to lead with that constant term over v to the 6th. Okay, this would be kind of the correct way of finalizing this exponent problem here. Okay, so we'll put a box around that, and then at this point and at this point only will I begin to look for the answer up here in my answer choices. See, there we go. So it's going to be C. All right, and that's number 1. So number 2 is going to give us an opportunity to apply these properties again. So first we'll start by writing 2a to the 4th b raised to the power of 0 times 2b to the 4th. All right? There's actually multiplication occurring between all these terms, so I don't know why the software only chooses to put random dots, but they're all being multiplied together. So remember, our first little help is to go ahead and put ones anywhere where there's no exponent written. And now we can go ahead and start combining like terms. So I'm going to work with the 2's as if they were just letters. And I see I've got A there, but no partner A. And then I've got 2 B's. Right? I always feel like I'm playing a game of cards here. Okay, like Go Fish. Okay, so here we go. We're going to combine those 2's together. So I'm going to treat the 2's just like they were letters. Right? I'm going to raise 2 to the power of 1 plus 1. See, I'm adding those exponents right there. And then I'm going to multiply that by a to the 4th. Remember, it has no other term to combine with. Then I've got b raised to the power of 0 plus 4. Okay? And we'll just go ahead and continue there. 2 raised to the power of 2 times a to the 4th times b to the 4th. Now, we don't leave constant terms exponentiated like that. We're going to go ahead and actually multiply that out. So 2 to the 2nd power is equal to 2 times 2, which is just 4. So we're going to write 4a to the 4th, b to the 4th. Now, it's very common to go ahead and list the letters. There's 2 rules. So first we go with the highest exponent first. But you see both of these have exponents of 4. So we will now switch to our second rule of writing mathematically, which is to go ahead and list the letters in alphabetical order unless there's something else going on. So that's how I would finish writing this problem. And I would go ahead and put that into a box. Maybe. I don't know what's going on with the box. All right, let's see if we can get that centered there. And there we go. So let's go see now if we've got 4a to the 4th, b to the 4th is one of our answer choices. There it is. So we'll go ahead and circle this here and call that good. All right, so we've got 2 problems done. I hope you're finding that this is more manageable than you at first thought. Okay, so let's move on to number 3. And again, of course, we're going to start by just rewriting it. 4m to the 3rd power, n to the negative 4th power, times 2m to the 2nd power, times n to the negative 4th power. Okay? So let's zoom in on this guy and start working it out. Again, I go ahead and put these 1's here. I'm just trying to work my problem-solving methodology. It's always good to have a problem-solving methodology. Now let's start highlighting common terms. I see a pair of m's and I see a pair of n's. Right, so I know I'm going to combine those. Now the 4 and the 2, they can be combined. It's just simple multiplication. So I'm going to show all the steps here. This is 4 times 2. Okay, times. And now I'm going to write m and raise it to the power of 3 plus 2, since those are the 2 m exponents, times n raised to the power of negative 4 plus negative 4. All right. Okay. And so we're going to continue here. Okay. So 4 times 2 is 8. Go ahead and write an 8. Times m to the 5th power, 3 plus 2 is 5, times n, now remember this is negative 4 plus negative 4, so that's actually negative 8. All right, now remember, n to the negative 8 power is equal to 1 over n to the 8th power. That's that negative exponent rule. And so I'm going to rewrite this as 8m to the 5th over n to the 8th power. Okay, and that's how I would finish that problem. And we put the red box of correctness on there. Call back to a great student of mine, Jay, who invented that idea. And let's go hunting for the answer. Here we go. So, I always have a little deal that I make with myself that I'm not going to look at the answer choices until I'm actually ready, like with my own answer. That way I don't find myself trying to back plug answer choices. I just don't want to feel like I'm cheating. All right, so we're on number 4, and we start rewriting 4v, and then u to the negative 2 power times 4u to the 4th power. Okay, right away I'm going to give the v a 1, and I notice that I've got common u terms, and I've actually got common 4 terms. So just to be consistent, I'll go ahead and give those ones, and let's begin. So first we'll start with the 4s. So I've got 4 raised to the power of 1 plus 1 times v, which has no partner, times u raised to the power of negative 2 plus 4. Okay, so we'll just kind of continue working there. So this is 4 raised to the power of 2, 4 squared, v, and then u raised to the power, negative 2 plus 4 is positive 2. Okay, so just a little bit of a sidebar here. 4 to the 2nd power is equal to 4 times 4, which is equal to 16. So my final answer will be 16. And I'm going to go ahead and list u squared first and then v. I don't know if that's how the answer will be listed in the homework assignment, but it's how I would choose to do it. Okay, and let's go hunting, and sure enough, they've listed the letters in a different order, but properties of multiplication allow us to put the letters in whatever order we want when they're being multiplied. Okay, so moving on. It's all pretty straightforward there. Okay, now when we get to number 5, things seem to take a turn, and it's because of these parentheses. The parentheses seem to terrify everyone, but there's really no big deal. It's actually got its own exponent rule, and it's called the power rule. So we actually need to just look here at the power rule. You need to understand how to do this. So this is the power rule for exponents. If I have a raised to the power of m, then that's in parentheses, and I raise that to the power of n, then what I'm going to do is multiply these together. It's kind of like the distributive property for exponents. So that's going to give me a to the power of m times n. Now that's quite different from the product rule. Okay, remember the difference between the product rule and the power rule is vast. So the product rule was a to the m times a to the n equals a to the m plus n. Do you see how these differ from one another? There's no parentheses down here. This is how you have one power, one base with a power raised to yet another power. Okay? I'll give you a quick example and then we'll jump into the problem. If I have x raised to the power of 5 and this is squared and then that is cubed, then I'm just going to daisy chain multiply all of this. So this is going to equal x raised to the power of 5 times 2 times 3. So in that case it would be 30, right? X raised to the power of 30. So that's just a quick example of how that works. You can nest the parentheses all you want. Okay, so this is the power rule that we're going to be working with primarily in this problem, at least at first, and then I'm sure it will resolve to other properties. So first we've got to rewrite this huge thing. It's going to be annoying. So we're going to write x squared y to the 3rd power, which we say is cubed, y cubed, times, now open parentheses, 2x cubed, y to the negative 4th power, close that parentheses, cube that entire parenthetical expression, and then close the parentheses and square the entire. These parentheses close off this one, and then change the color here. These parentheses close. So they're kind of nested, okay? Now, we're going to deal with the internal parentheses first. So the first thing I'm going to do is deal with this. All right, and then I'll deal with the rest of it. So remember, the power rule says I'm going to multiply that external exponent right here by all of the exponents. I'm going to give that 2 a 1 because I'm actually even going to multiply that 3 to the 1 exponent of that 2. All right, so the first step here, we're going to just rewrite x squared y cubed. And now I don't need the green parentheses anymore. I can just say times 2 raised to the power of 1 times 3, okay, times x raised to the power of 3 times 3, times y raised to the power of negative 4 times 3. Okay, and then this close the original parentheses off, and we're going to square the whole thing. All right, so we're going to need to do some cleanup work here. This is going to equal, open parentheses, x squared y cubed times 2 to the 3rd power times x to the 9th power, 3 times 3 is 9, times y to the negative 12th power, negative 4 times 3 is negative 12. And I'm going to square that whole thing. Well, now I'm going to reapply the power rule and multiply that 2 times every exponent inside the parentheses. Okay, so it's going to look like this. We have x raised to the power of 2 times 2 times y raised to the power of 3 times 2 times 2 raised to the power of 3 times 2 times x raised to the power of 9 times 2 times y raised to the power of negative 12 times 2. Okay. So we're just going to continue working out our problem here. X to the 4th power, y to the 6th power, 2 to the 6th power, x to the 18th power, y to the negative 24th power. Now I'm going to remember that all this is being multiplied here. Okay. Now I'm going to search for my common terms, and I'm going to use the product rule to deal with these. So I've got the x's and I've got the y's. So here's what I'm going to do next. I'm going to do the x's together, right? And then I'm going to do the y's together, and then we'll stick this 2 over here. So I've got x raised to the power of 4 plus 18 times y raised to the power of 6 plus negative 24 times 2 raised to the power of 6. All right? So this gives me x raised to the power of 22 times y raised to the power of 6 plus negative 24. It gives me negative 18 times 2 to the 6th power. Now, 2 to the 6th power is equal to 2 times 2 times 2 times 2 times 2 times 2. Okay, well, the thing is, 2 times 2 times 2 is 8. So I've got 8 times 8. So this must equal 64. All right, so this is 64 over here. Now remember, the negative exponent here means we're going to have to write y to the negative 18th as 1 over y to the 18th. And so my final answer will be 64 x to the 22nd power over y to the 18th power. And that'll finish that problem up right there. Nice and easy. It's a happy little problem right there. Let's go look for the answer. And there it is. So it's going to be A. Very interesting. Look at all that math. If you write all this down on your paper, you should be proud of yourself. It's a lot of work. Very cool. Love this stuff. All right, so here we go with number 6 here. I've got open parentheses x to the negative 2nd power times y to the negative 3rd power times x to the third power times y to the negative first power. And the whole thing is going to be squared. All right? So you see here I've only got one pair of brackets, and every term inside the parentheses already has an exponent, so I can just immediately use the power rule of exponents to distribute and multiply that 2 to every term inside. This time we'll save a little time and just do it in our heads. This is going to be x raised to the power of negative 2 times 2, that's negative 4. And then y raised to the power of negative 3 times 2, that's negative 6, times x raised to the power of 3 times 2, that's positive 6, times y raised to the power of negative 1 times 2, that's negative 2. Okay. Now remember, we're going to combine like terms using the product rule for exponents. So first I'm going to combine the x's, then I'll combine the y's. So this is going to equal x to the negative 4 plus 6, all right, times y to the power of negative 6 plus negative 2. Okay, well, negative 4 plus 6 is positive 2, so this is x squared times y, negative 6 plus negative 2 is negative 8. Remember, okay, you've got y to the negative 8. You have to rewrite that as 1 over y to the 8th. So our final problem will be x squared over y to the positive 8th power. Okay. Oops. Let's try that again. There we go. Okay. Great. Let's go look for that. And there it is. Okay. B. Alrighty. Moving on. Okay, looks like we have really hit an interesting problem here. These are so much fun because you get to apply all of the exponent properties in one problem. So this is just super exciting. Alrighty, so first things first, we've got to have that grit and determination to rewrite this whole thing. So let's just get into it. I'm going to write 2x squared z to the 0 power, close the parentheses off, exponentiate to the negative 4th power. And here having a straight edge of some kind is a huge help. If I can get it to stay on 0. I draw this huge fraction bar here, open parentheses, x squared y to the 4th z to the 3rd times 2 times x to the negative 1st times y to the 4th, the whole thing cubed. All right, you see this whole thing down here is raised to the 3rd power. So let's go put all of our extra ones where they are needed, and then we can begin. We'll start on top by multiplying negative 4 times all of these exponents. You know, we'll go ahead and do the same thing on the bottom. It's hard to draw, but I'm going to distribute this 3 to all the exponents down here as well. Okay, just not going to draw the lines because it's too tight. So this is going to equal on top 2 to the 1 times negative 4 is to the negative 4, okay, times x raised to the power of negative 8, right, 2 times negative 4, negative 8, times z raised to the power of 0 times negative 4, which is just 0. Now here I feel like I should do a sidebar. We need to talk about the 0 exponent rule. And what that basically says is, you know, anything raised to the power of 0 equals 1. So z raised to the power of 0 equals 1. 5 raised to the power of 0 equals 1. Okay? Bob raised to the power of 0 equals 1. Okay? So that's the 0 exponent rule. So you see this right here, this just equals 1. The whole thing. Right? So that'll disappear. Just keep an eye on this. That's going to disappear in the next step. Alrighty, so let's go ahead and get that ruler out. Now down here I've got x to the 6th. 2 times 3 is 6. y to the 12th, 4 times 3 is 12, z to the 9, 3 times 3 is 9, times 2 to the 3rd, 1 times 3 is 3, times x to the negative 3, negative 1 times 3 is negative 3, times y to the 12th, 4 times 3 is 12. Okay, so down on the bottom, I'm going to combine like terms. I've got x's and I've got y's. Okay, so upstairs, we're just going to leave everything as is. 2 to the negative 4th, x to the negative 8th. And now remember, this guy right here is just 1, so times 1. But we don't actually have to write that. Okay, and ruler time. Now I'm going to combine the x's. So that's 6 plus negative 3 gives me x to the 3rd power. Then I'm going to combine the y's. So 12 plus 12 is 24. And then z has no friends, so put the letter z to raise to the power of 9. Now 2 to the 3rd power. All right, so 2 times 2 times 2, that's 2 to the 3rd power. And that equals 2 times 2 is 4, 4 times 2 is 8, so that's 8. So we just write 8. Now continuing on, 2 to the negative 4th. All right, so that's going to come downstairs. The x to the negative 8th is also going to come downstairs. So you see we're not going to have anything up here at all. So we're actually going to have a big 1 upstairs. Let's bring that ruler up. And down here I'm going to have 2 to the 4th power, x to the 8th power. That's what these are. Okay, they've come downstairs here, and they've become positive. And then I've got x to the 3rd power times y to the 24th power times z to the 9th power times 8. Okay. So let's figure out what 2 to the 4th power is real quick. 2 to the 4th equals 2 times 2 times 2 times 2. So remember, that's 8. 8 times 2, this is 16. Okay, so I've got 1 over, now I've got 16 here and 8 here. So 16 times 8, this is 48. So it's 128. So I'm going to have 128 down here. And now I've got to combine my x's. That's going to be x to the 11th, y to the 24th, z to the 9th. And this is the final answer here. Okay. Now let's go see if we can find that answer. Hey, look at that. Right there. Very cool. Okay. And on to the final problem. Oh wow, this just looks like so much fun. Can't wait to do this. If you find this interesting, you want to become a math teacher. All right, so we're going to rewrite this. 2kj to the negative 3rd power over, huge fraction bar here, 2hj to the 0, k to the negative 2 times h to the 0 times k to the 3rd power, k cubed, times, and here they're going to throw something power rule at us, k to the 4th raised to the 2nd power. All right, so first of all, I want to identify this j to the 0 and h to the 0. Those are just 1, so they kind of cancel out. They're really just red herrings. Okay, does everyone understand this reference here? I just said red herring. All right, this means it's trying to trick us, okay, or lead us astray. That's what red herring means. All right, so when I said that j to the 0 was a red herring, that's because it really just equals 1. Same thing with h to the 0, it equals 1. All right, so getting back to the problem, I noticed something from old school math. I've got a 2 here and a 2 here. Well, those cancel out, so that makes my life a lot easier. So on top, I've got a k, and I'll go ahead and write j to the negative 3. We'll deal with that later. We will deal with it, but we'll deal with it later. Now over here, I'm going to go ahead and multiply the 4 and the 2. And so what have we got left? We've got an h here we don't want to forget about, so we'll put h times k to the negative 2nd power. I'll show you what to do with that. Times k to the 3rd power times k to the 8th power, because 4 times 2 is 8. Alrighty. So remember, this is to the 1st. All right, now down in the denominator, I've got some like terms here. Okay, so first let's rewrite the numerator. K times j to the negative 3rd. Again, we're going to deal with that in a second. Downstairs, I've got h times k raised to the power of negative 2 plus 3 plus 8. So negative 2 plus 3 is positive 1. Positive 1 plus 8 is positive 9. So I've got k times j to the negative 3 over h times k raised to the power of 9. Okay, so here I've got k to the power of 1 on top, k to the power of 9 on the bottom. This needs to go downstairs, so that needs to come down here. And then we have to apply a property that we haven't seen yet, which is called the quotient rule or the division rule. Okay. So the division rule for exponents says if I have a to the m and I'm dividing by a to the n, that is equal to a to the m minus n. Written another way, I have a to the m over a to the n. It's equal a to the m minus n. All right, so here I've got, in this example, k to the 1st divided by k to the 9th. So it's going to be k to the 1 minus 9. That's going to give me k to the negative 8. So let me just show that happening here, okay? So this is k to the 1 minus 9 all over h j to the 3rd. This guy came downstairs. Now remember, k to the 1 minus 9 is k to the negative 8th power over h j to the 3rd power. But remember, I can't have negative exponents, so I'm going to move that downstairs. So finally I'll end up with 1 on top over h j to the 3rd, k to the 8th. All right, let's go find that. 1 over j to the 3rd, h k to the 8th, d. All right. Well, you can't say that I didn't give you a hand here. This is all the work that we did just now, and I really hope that you found this helpful and that after watching this video you have a better idea of how to apply the exponent properties in algebra. Thanks for watching.